All right, welcome ladies and gentlemen. This is video number 6 in our atomic structure unit. So you're going to need your notes open to where it says video 6. And again, a periodic table would probably be helpful for this. So this video is about something called ground state versus something called excited state. And our goal with this is to understand the changes in energy and the changes in location that occur when an electron moves between these two states, between something called ground state and something called excited state. So first of all, what is ground state? Ground state is not referring to ground beef or ground turkey. Instead, it is referring to when electrons occupy the lowest available energy shell that they can. So what is the lowest energy closest to the nucleus shell that they can occupy? Sometimes it's the first shell, but maybe a given electron can't actually get that close because all the other electrons are already there before it. So maybe its ground state is, let's say, the third shell. So our ground state is when our electrons are low energy and as close to the nucleus as they can possibly get. They're very stable when they're in their ground state. They're in their lowest energy configuration. But the thing is, electrons, despite this being a really low energy system for them, they're not always found in their ground state. Electrons can move because electrons are weird and they do some really weird stuff. So they can move, and when they move, they go into what is called the excited state. And this excited state, I mean, it's kind of in the name, excited. They're excited. So what does that mean? It means that they absorbed energy. Right, they're excited. They have lots of energy. If you think about an excited little kid, they're running around. They have all kinds of energy. Now, that energy that they absorbed, it would have come from somewhere. Maybe you heated the atom. Maybe you ran electricity through the atom. Maybe some light was hitting the atom. So that electron absorbed energy. They took in energy. And when they took in energy, they have too much energy to stay in their low energy shell. So what do? They move. The electron moves. It moves. Where does it move to? It moves to a higher energy shell. It has too much energy, so it becomes more energetic, and it moves farther away from the nucleus, right? Farther away from the nucleus, and has more energy. But this state, this excited state, it's unstable. The electrons are not going to hang out in their excited state. They've got too much energy. So what they want to do is actually return back to their ground state where they're nice and safe and comfortable and they're super low energy and they can go back to sleep, basically. So our electrons, they're going to return to the ground state. And they will do this quickly. They tend not to hang out in the excited state very long. And they'll return to the lower available shell. And this is a massively huge important point, so I'm going to all kinds of emphasize it and point to it. When electrons return from their excited state, the super high energy farther from the nucleus excited state, when they return from that excited state to the ground state, they release energy in the form of light. That excess energy that they have to get rid of it. So they give it off, and the form of energy that it takes on is light energy. So we can actually see the electrons returning from their excited state to their ground state because of the light that the electrons are in fact giving off. We're going to draw this, and we're going to draw this idea of ground state to excited state. We're going to start with a lithium atom. So lithium atom, 3 protons, 4 neutrons in the nucleus. The electron configuration is 2-1. This is the ground state configuration. So I'm just going to draw this in. I think you have the electron configuration drawn into your notes already, but 2 electrons in the first shell, 1 electron in the second shell. And in order to go to the excited state, we have to add energy. So we're going to push some energy into the system. This is the same thing as saying that the electron absorbed energy. The electron took in energy that we added from the outside. So right now, all the electrons are in their lowest energy state, but now we're going to push them. We're going to change them around. And in doing that, I'm going to redraw this. One of the electrons that was in the first shell is actually going to move up to the second shell. This electron right here, it shouldn't really be there. It doesn't belong there. It belongs in the first shell. It leaves an open position in the first shell. So now notice that the electron configuration has changed, right? Instead of being two electrons in the first shell, one in the second, now there's only one electron in the first shell, but two in the second. This is called an excited state. This right here is excited state, because there's an electron that has too much energy. It's an excited electron. It's in a higher shell than it's supposed to be. So the electron absorbed energy. We actually use the verb jump. The electron jumps to a higher energy level, and it will not stay here though, right? It's an excited state, but it's not going to hang out like this permanently. That electron isn't supposed to be there. So basically almost immediately, that electron that was in that second shell, I'm going to add these guys back in, it is going to return to the first shell. It goes back to where it belongs. That's its lowest possible electron configuration. When that happens, that process of that electron returning, that electron gives off light. And the light that it gives off is the light that we see in those spectra that look like this, that have the different bands and different lines, and maybe a line out here. That light, that energy that's giving off in the form of light is actually turning into that band that we see. And each light, right, each element will have what's called a bright line spectra, or an atomic spectra, that is actually unique to it. The way that the different electron configurations for each element, the way that they move to excited state and then return to the ground state, the light that they give off, it's unique to every element. So every element has a different pattern of this spectra, this atomic spectra, this bright line spectra that we see. And once that electron is back in the ground state, then it's done emitting light. Is not going to give off any additional light, but again, it's in that process of returning from the excited state to the ground state that the electron is capable of emitting light that we can then visualize, we can see, and actually use that to identify an atom.